Hello everyone. Today I am going to make a video tutorial on binary subtractions. We all are familiar with the decimal subtractions, but how to perform the binary subtractions we will study in this tutorial. Now let's begin the class. Heck, first of all, what is the subtractions? Let's understand what is the subtraction. Subtractions means to remove certain things from the main thing. That means this gives residue. In a decimal subtractions, for example, 10 minus 6. If we subtract 6 from the 10, then this gives result 4. 4 remains there. Similarly, how to perform the binary subtraction? We will study here. Subtractions is possible only if we subtract a small number from the big number. Yes. If we try to subtract a big number from the small number, we do the same process. We subtract a small number from the big number and place the minus signs because it gives the negative result. Similarly, today I am going to make a video on how to perform a binary subtractions. Binary subtractions takes both binary input, two number. We need two number to perform the subtraction operation. One is subtrahend and other is minus. That is, both these inputs number are in binary format and it produce binary output also. Now let's perform. Let's do some example. 1 1 0 1 minus 1 1. Now let's understand from this example how to perform this subtraction. Now this is similar. This subtraction is similar to the decimal subtractions, except we use 1 0 combinations of 1 0 in this number. Now what could we do? First of all, we need to arrange this number in this way: 1 1 0 1 minus 1 1. Now how to perform subtractions? We need to begin from right hand side to the left hand side. Now 1 minus 1, 0. 0 minus 1. It is possible? No, not possible. Subtractions big number from the small number is not possible. So that we need one borrow from its left hand side number. So that when it take one borrow from its left hand side digits, then this 0 become 10. 0 become 10. 0 is converted into 10 because this one is one positions higher than this positions. This becomes 10 and it 1 is converted into 0 because it goes to the next positions. Now if we subtract 1 from 1 0, then it gives 1 1. Now and here remains 0. Now 0 goes down and 1. This gives 1 0 1 0 result. Before solving other example, let's see how to perform. What would happen to subtract one digit in a different case? For example, A, B. Suppose A and B are two digit. Difference. Borrow. Now, look at here. What? How many combinations of two digits we can form? There are 2 to the power 2. That means 4 combinations. 0 0 0 1 1 0 and 1 1. Now difference means let's perform A minus B operations here. A minus B operations. 0 minus 0 0, it gives result 0. And it need borrow from another positions? No. 0 minus 1, is it possible to subtract? No, not possible. So that A takes one borrow from another number. from somewhere and it becomes 1 0. That means it take borrow. That means borrow and it become 10. 10 minus 1, it gives result 1. And in the third case, 1 minus 0, it gives difference 1. It take borrow from another position? No. 1 minus 1, 0, 0. Now, these are the available case for the subtractions of the 2 digit. Now, we use the same concept to subtract the complex number. Now, look at another example. Suppose 101 minus 101.101 minus 1. Only 1. Now, to perform this subtractions, we need to make the same format for the both number. First of all, we need to make the same format for the both number. Now, we need to make 1 equivalent to this format. How to do this? To perform this 1. First of all, let's me to write this number first of all. 101.101 and 1. This is not 0.1. This is the integer 1. So that integer 1 is need to write before decimal point. Now 1. This one is this. Now for the integer number, we can append any number of 0 to the left hand side. That means we can append any number of 0 to the left hand side. For the fractional number, we can append any number of 0 to the right hand side. Now 1 is converted into 001.000. We can change in this way. Now this number do not change the quantity or value of the 1. Now why we made this? To make the difference operations easy. Now we'll perform the subtraction operations. 1 minus 0, 1. 0 minus 0, 0. 1 minus 0, 1. And dot. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. This gives this result. If we subtract 1 from this number, then this will give this result. Now let's see another example. One 1011 minus 1.11. Now let's perform these calculations. Now let's first of all write this number 1101.1011. Now we need to write this number below this number. Dot. We have to take dot as a reference point, and we need to make alignment of integer and fractional number both on the reference of this decimal point. Now we need to write straight decimal point, straight another decimal point straight just below to this decimal number, and we need to write the remaining digits. How many digits are available in the integer? There are 2 digits. That means we need to write just below these 2 integer digit 1 1, and fractional parts contain 1 1 1 1. Now we have to make alignment of these decimal numbers. Now to make the same length, or to convert this number to the same format of this number, we have to add sufficient number of 0. Now for the integer number, we can append any number of 0 to the left hand side. For the fractional number, we can append any number of 0 to the right hand side. Now we need to perform the subtraction operations. We need to begin from right hand side to the left hand side, one by one. 1 minus 0, 1. 1 minus 0, 1. 0 minus 1, not possible. so that it take one borrow from its left hand side and it become 10 and it becomes 0. 10 minus 1, 1. Sorry, it is pronounced as 1 0. 1 0 minus 1, 1. And 0. It's become 0. And 0 minus 1, not possible. Again, it takes one borrow from its left hand side and it become 1 0. It become 0. 1 0 minus 1, 1. And dot. It is 0 now. 0 minus 1, not possible. So that it asks for another digit to take the borrow. But it do not have the number. It is already 0. So that it's again asks borrow from next digits. Now it becomes 0 and it becomes 10 after taking the 0. Now it again gives 1 to these positions and this numbers become 1 0 and it remains 1. That means 1 0 minus 1, 1. 1 minus 1, 0. 0 minus 0, 0. And 1. Now this would be the result of subtractions of these two numbers. Now this is one case. Another case, B. Let's see B. 1 1 dot 1 1 minus 1 1 0 1 dot 1 0 1 1. Then what would be the result of this expressions? Now I have just changed the order of subtraction here in this case. Now this gives the result 1 0 0 1 dot 1 1 1 1. Now this gives the same results. This gives the same result. That means its result is 1 0 0 1 dot 1 1 1 1, except we need to append minus sign because we are subtracting big number from the small number, so that we need to append minus signs above this result. Now this is the final result. In this way we can perform any subtractions of the binary number. For any binary number we can now perform the subtractions. Now let's take another example, one complex example. Simple number but complex example. 1 minus 0.11. How to perform these calculations? Now we need to change these two numbers into the same format. Format means equal number of length, equal number. For both integer and fractional part, we need to make equal number of digit for both number. Now 1 can be converted into 1.00. We can append any number of 0 to the right hand side from this decimal number. And 0.11. This is the second number. Now it is not possible to subtract 1 from 0, so that it asks borrow from the next bit, but it also contains the 0. It do not have anything to give to this. Now it again asks for 1 from its nearest digit left hand side, and it gives 1. After giving 1, it becomes 10 and here remains 0. And it again gives 1 and these positions become 10 and here remains 1. Now 1 0 minus 1 1, 1 minus 1 0 dot 0. This will give the result 0 dot 1. In this way we can perform the binary subtractions for any binary number. This is quite similar to the decimal subtractions, but number used here is the combinations of 0 and 1. Thank you very much.